Hey, science enthusiasts! Today, we have an exciting breakthrough in the field of orthopedic surgery that could revolutionize the way we treat bone fractures. Let's dive into the world of synthetic bones designed by AI. Researchers have developed a bone-like synthetic material using machine learning and 3D printing aimed at enhancing orthopedic treatments. This new material could potentially replace traditional surgical methods, reducing complications and improving healing times. Despite their irregular architectures, natural materials like bones and bird feathers have an extremely efficient approach to physical stress distribution. However, understanding the exact relationship between stress modulation and their structures has long eluded scientists. In a recent study, researchers used machine learning, optimization, 3D printing, and stress experiments to develop a material that replicates the functionalities of human bone for orthopedic femur restoration. This study has revealed new insights into the complex relationship between bone structure and stress distribution. Femur fractures, common among elderly individuals, pose significant challenges. Conventional methods involve attaching a metal plate with screws, which can cause complications such as loosening, chronic pain, and further injury. The research, led by Professor Shelley Zhang from the University of Illinois Urbana-Champaign, along with graduate student Yingqi Jia and Professor Qi Liu from Peking University, introduces an innovative approach to orthopedic repair. Their work, published in Nature Communications, uses a fully controllable computational framework to produce a material that mimics bone. Professor Zhang explained, "We started with materials database and used a virtual growth stimulator and machine learning algorithms to generate a virtual material, then learn the relationship between its structure and physical properties." In the lab, the team used 3D printing to fabricate a full-scale resin prototype of the new bio-inspired material and attached it to a synthetic model of a fractured human femur. This tangible model allowed for real-world measurements and testing. Zhang said, "We confirmed that it is possible to grow a synthetic material in a way analogous to how biological systems are built. This work helps build materials that will stimulate bone repair by providing optimized support and protection from external forces. This technique can be applied to various biological implants where stress manipulation is needed." Professor Zhang mentioned, "The method is quite general and can be applied to different types of materials such as metals and polymers. The key is the geometry, local architecture, and the corresponding mechanical properties, making applications almost endless." This breakthrough in synthetic bone materials designed by AI could revolutionize orthopedic surgery, reducing complications and improving recovery times. Thanks for joining us on this journey into the future of medical technology. Don't forget to like, subscribe, and hit the bell icon for more exciting updates on cutting-edge science and technology. See you in the next video. Remember, innovation in science and technology is paving the way for a healthier future. Stay curious and keep exploring.